Okay, here's the demo of the stage 2 of the project, and we compile the client and the server file first, and now we start running the server and the client. We have two clients trying to connect to the server at using port 80 to 80, and each client have its own listening port number. The first client is 9001. So now we start with the registration part, and the username will be Alice, and the password will be password 1 for this user. Now the user can log in with its name, password, and its listening port number 9001. And we do the similar process for another user, which also connect to the server using the server port number 8080. And first register his name Bob and its password 2. We can see on the leftmost panel, the server is receiving this message and showing the IP of the client. Now, after Bob was logged in with his password, now back to Alice, we can see that it can first use a command called list to see who is online. So she can see that Bob and Alice are both online, and then she can send a message to Bob using the send command. So the send Bob, and she sent a hello message, and we can see that on the rightmost panel, Bob received a message hello from Alice. So this is the implementation of online chat room, which was implemented with relay mode, and we will expand the implementation part later. And again, now Bob is sending message back to Alice using the same command send. Now is the code explanation part. First, we start with on a multi-thread server, we create a worker pool of Mac worker, which will be 10 in our implementation, and a shared task queue will be created to store client connections, and we'll use mutex and count logs to ensure thread safety. So here's our code. At startup, the server creates threads which run the worker thread function, and then we can also check the task queue which store client connection and synchronize by mutex and conditional variable here. So the main thread, when accepting new clients, it pushes them into the queue. And now we can scroll up to the worker thread processing, which fetch tasks from the queue and process client request using this part of the code. And finally, we can see each client is handled. Let me check. Here, each client is handled independently. For example, in the login and red comment down here, they update the shared user database safely using the mutex lock here. Now we explain how we implement the online chat using the relay mode, which the server act as a relay station to relay the message from client to client. Key part one is target identification, which the user database we can use the user database to ensure only login user can receive message, and the listener we implement in the client side can run a listener port that accept incoming message and display them to the user as we show in the demo video at the very beginning. First, we start with the command parsing in the server code. The server identifies a send command issued by the sender, and it should include target username and the message to be sent. The server then checks if the target user exists and is currently logged in by looking up the user database. Then if the target user is valid and online, then server creates a relay socket to connect to the target user's listening port and IP address. So after connection is established, the server connects to target user's listening socket and sends the message using this relay socket. So now we explain how our code implement message encryption with OpenSSL. So the first part is the handshake. So before exchanging messages, the client and the server establish an encrypt connection, and then the data can be sent and can be sent with the encryption and decryption using the SSL function, SSL write and read, and with the server's public key during the transmission. Okay, so here's our implementation. This is the server code, and both the client and the server will initialize the OpenSSL library and create an SSL context for encryption using this initialization function here. And after creation of SSL context, it loads its certificate and private key. The client also will create an SSL context, which is similar and is shown here. Here is the code for the client side, which also do the initialization part and the creating SSL context part. And now when the client will try to send the data far down, let me see here, and use the SSL write function for encryption. And back to the server side, we can see that when server is trying to read and receive this message, it will use the SSL read function at here. And now again, the server will generate some response, and the encrypted message will be again sent via SSL write.